but I'm not really sure how to find continuity, how to find differentiability.
Yeah, there's kind of a more
looking on a graph, like if there's like a sharp point, I don't think it's differentiable.
Right. Yeah, so there's definitely a more formal way to think about continuity. We have to see that the limit as x approaches 5. So the formal definition is the limit as x approaches 5 in this case, because we're looking at 5 from the left side of f of x. It has to equal the limit as x approaches 5 from the right side. So that just says that they have to meet at the same place from the left and the right. This is essentially what that means. They have to converge from the left to the same place. Converge from left and right. That's what this part means. And then there has to be a point there at f of 5. This has to be the same point. It can't be, because in this case, right, notice that the limit's the same, right? They both occur, they both converge from the left and the right. But if you have a point up here, then it's not continuous because the hole's not filled in. You need the hole to be filled in for it to be continuous.
Okay.
And then this part, it has to equal f of 5, which means the hole has to be filled.
Oh, I was just going to write that.
Yeah. Okay, so let's check continuity first. And how do we determine that?
Yeah, so I think you just set them up equal to each other, right?
How do we find the limit approaching from the left?
Yeah, so you look at what's less than 5.
Yeah, okay. So which function do we use?
You do negative, you use the top function, and then you set that equal to the bottom function because the bottom function is the right side of 5.
Okay. So what do you get then?
Well, I think you get that it equals each other.
Yeah, what'd you get for the top number?
5. Negative 22.
Yeah, this of f of x. Limit going from the left, negative 5 squared plus 3. Yep. Negative 22. Okay, what do you get for the right?
Negative 22.
Is negative 50. Yeah. Negative 10 times 5 plus 28 equals. And then what's the actual point? If you actually found f of 5, which function do you use?
I'm not sure how to find that.
So you just have to look at which if you look at these intervals, which one includes 5?
Top one?
Yeah, it's equal to 5. So then you just plug it back into the same one directly. And that would clearly be negative 22, right?
Right.
So do you see how these are all equal, which means that the left is going to meet up with the right, and then there's an actual point there, so it's continuous.
Okay. So then how do we find differentiability?
Yeah, so it's this kind of the same idea, but we have to, right, goes to the point. So differentiability is the same idea, except we're comparing the left slope and the right slope. And the right slope. So notice that so the formal definition is that the limit, if we're looking at 5 again, x prime, we have to look at the left derivative, and the left derivative has to equal the right derivative in order, or the right slope, in order for it to be differentiable.
Okay, so you basically just take the derivative of the top and bottom function then?
Yeah, exactly. And notice that will ensure, if these two slopes are equal, that will ensure a smooth curve. Notice that if these aren't equal, like for example, the left slope is like positive 2, and then the right slope is like negative 1, that's what creates a corner point. Because when the slopes are different from the left and the right, it'll create a sharp edge. Because it will be a sudden change in the slope.
Oh, you're saying that sharp points are created when You have two different slopes.
Yeah, from the left and the right. So that's why it's not differentiable.
In this case?
Well, so we have to check in this case, right? So I'm just saying that that's an example of, of when it's not differentiable is when you, the reason why, yeah, exactly. Like you said before, the reason why you have a sharp corner is with the left slope doesn't equal the right slope.
Mm-hmm.
Okay, so how do we check that then?
So to check this, you take the derivative of the top function.
Okay.
So negative 2x equals the bottom function, which is just negative 10. And then you plug in 5 for x, and then you get that negative 10 equals negative 10. So therefore, it's differentiable.
Negative 10. Okay. Limit as x approaches 5 from the right, f prime of x. Yeah, negative 10, right.